Okay, welcome back to Math 1500 Applied Business Mathematics at Connecticut State Community College. Today we're talking about section 5.2, matrix multiplication. When we multiply matrices, there are some things we need to keep in mind, okay? First of all, in order to multiply matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So for example, if I want to multiply a 2 by 4 matrix times a 3 by 3 matrix, I cannot do that multiplication because the number of columns in the first does not equal the number of rows in the second matrix. So I cannot multiply that. If I wanted to multiply a 2 by 4 times a 4 by 3, that would be okay as long as these inner two columns in the first, rows in the second matrix match. In addition to that, because those fours are the same, notice at the outer here, the number of rows in the first column, in the first matrix, and 3, the number of columns in the second matrix, that will become the dimensions of my resultant matrix, okay? Now, in order to multiply matrices, to find each entry in the resultant matrix, you multiply an entire row of the first matrix by the corresponding column in the second matrix. So, here's an example, and it's a bit of work, but we've got a 2 by 2 times a 2 by 3 matrix. Because 2, the number of columns in the first matrix, and 2, the number of rows in the second matrix are the same, I can do this matrix multiplication, and my result will be a 2 by 3 matrix. So I want to set up my 2 by 3 matrix first. Give a little bit of room there. There are going to be 6 elements here. 1, 2, 3 elements in the first row, and 3 elements in the second row. Okay. Now to do that, I'm going to multiply the first row times the first column. 3 times 4 is 12. And then negative 1 times 1 is negative 1. That's going to give me 12 minus 1 is 11. To find my second term, this term here that's in the first row, second column, I'm going to do the first row times the second column. So 3 times 6 is 18. Negative 1 times negative 2 is 2. And so we get 20. To find the element that is in the first row, third column, I'm going to multiply the first row times the third column. So 3 times 3 is 9. Negative 1 times negative 5 is a positive 5, and so we get 14. So now we have the first row of our matrix. Let me try to make that a better looking 14. Moving on to the second row, to get the element in the second row, first column, I'm going to multiply the second row of the first times the first column of the second matrix. So 6 times 4 is 24. 2 times 1 is 2. So we get 26 for the element in the first row, second column, try again, second row, first column of the resultant matrix. To get the element that's in the second row, second column, I'm going to multiply the second row times the second column. So 6 times 6 is 36. 2 times negative 2 is a negative 4, and that result is 32. Finally, for our last term, that's in the second row, third column, I'm going to multiply the second row of the first times the third column of the second matrix. 6 times 3 is 18. 2 times negative 5 is negative 10. And so that result is 8. And then this is the result of multiplying those matrices. Okay, it's the same process again and again. I could do multiple examples. It's the same process. To get the element in the first row, first column, you multiply the first row times the first column. I can also use my calculator to do matrix multiplication. I will tell you I've already entered matrix A, 3, -1, 6, 2 into my calculator. I've also already entered matrix B into my calculator, 4, 6, 3, 1, -2, -5. Let's quit out of here. To do the matrix multiplication, I simply need to select matrix A, times. I can press times, or if I don't, the calculator will interpret multiplication, A times B, and we get the matrix 11, 20, 14, 26, 32, 8. The same as what we had. Please notice in example 2, I have reversed the order of multiplication. Instead of A times B, I have matrix B times A. I want to stress to you the fact that matrix multiplication is not commutative. You may have noticed that I made the bullet point up here that matrix multiplication is not commutative. Here's the first example. Matrix B is a 2 by 3 matrix. Matrix A is a 2 by 2 matrix. Notice the number of columns in matrix B is not equal to the number of rows in matrix A. I can't even do that multiplication. I can't start. Because if I were trying to do it, I would need to do the first row, 4, 6, 3, times the first column, 3, 6. I can do the 4 times the 3 and the 6 times the 6, but there's nothing to multiply that 3 by. And so it just doesn't work. In fact, if I tried in my calculator to do matrix B times matrix A, I expect my calculator is going to yell at me, and it does. It says that there is a dimension mismatch. That means that there's a mismatch in the dimensions. Check the size or dimensions of the lists or matrices. Okay, so there's a problem with matrices. I cannot reverse the order of that matrix multiplication. Okay. Number 3, notice here we have a 2 by 4 times a 4 by 4 matrix. Because of the 4s, I can multiply. My result will be a 2 by 4 matrix. I like to set up the 2 by 4 matrix. Okay. I'm going to do 2 times 1, 0 times -2, -1 times 7, and 3 times 1. 2 times 1 is 2. 0 times -2 is 0. You know what? I think I'm going to need some room here. -1 times 7 is a -7. And then 3 times 1 is 3. When I add those up, 2, -7, 3, I get -2. I'm going to erase my lines. Now I'm going to do the first row times the second column. 2 times 4 is 8. 0 times 5 is 0. -1 times 2 is -2. 3 times 5 is 15. 8 minus 2 plus 15 is 21. Moving on. I said that was a 4 by 4. It's a 4 by 3. Please forgive me. So that's even better. My resultant is not going to be a 2 by 4. My resultant is going to be a 2 by 3. So now we need to do the first row times the third column. 2 times 3 is 6. 0 times 1 is 0. -1 times 0 is 0. And 3 times -3 is -9. 6, 0, 0, and -9 is a -3. It does not hurt to set up this matrix up here, kind of like it's a scratch work as you're learning and practicing multiplying matrices. Moving on, to get the second row, now I'm going to do the second row times the first column. 1 times 1 is 1. Negative 2 times negative 2 is 4. I'm going to add these together. 2 times 7 is 14, and 4 times 1 is 4. So I've got 1, 4, 14, and 4, I believe is 23. Let's go back out of here. 1 plus 4 plus 14 plus 4 is 23. Second row times the second column, so 1 times 4 is 4. Negative 2 times 5 is negative 10. 2 times 2 is 4. And then 4 times 5 is 20, so it looks like we should get 38. And then finally, second row times the third column. 1 times 3 is 3. Negative 2 times 1 is negative 2. 2 times 0 is 0. 4 times negative 3 is a negative 12. And that looks like we should get a negative 11. And there we have the matrices multiplied. Again, I could use the calculator. I've shown you how to do that. It would just be a matter of changing your matrix A and your matrix B. Okay. An example of matrix multiplication. Okay, this is a very simple example, but you'll notice that in this table here, I could write this as a matrix where I've got the store and the items. I have 20, yeah, that's a 20. I have 20 wiper blades, 10 bottles of fluid, and 8 floor mats. Also notice that the A Plus Auto Parts store sells wiper blades for $7 each, cleaning fluid for $3 per bottle, and floor mats for $12 each. I can set that up as a matrix also, but I want to be careful how I set it up. Notice that one of the dimensions is the items: wiper blades, cleaning fluid, and floor mats. I'm going to set that up as a row matrix where the row is price or money and the columns are items. $7 for a wiper blade, $3 for cleaning fluid, $12 for floor mats. Now you'll notice that things are lined up. Wiper blades, cleaning fluid, floor mats. Wiper blades, cleaning fluid, floor mats. If I now simply multiply these two matrices, you notice we have a 1 by 3 times a 3 by 1 matrix. Because those threes are the same, I can do the multiplication, and my resultant will be a 1 by 1 matrix, which is something we've not seen a lot before. But to do the matrix multiplication, 7 times 20 is 140, 3 times 10 is 30, 12 times 8 is 96. So if I add 140, 30, and 96, we get a total of 266, and that is my 1 by 1 matrix. Okay, we've used matrix multiplication to find the total revenue generated by the sales of these items. If I sell all 20 wiper blades for $7 each, all 10 bottles of cleaning fluid for $3 each, and all 8 floor mats at $12 each, I should have a revenue of $266. Okay. Last topic, last item for this video is what we call the identity matrix. The n by n identity matrix we call the identity matrix I. That's a capital I. It's a square matrix. So notice it's an n by n identity matrix. There's a 1 by 1, a 2 by 2, a 3 by 3, 4 by 4, and so on. 1's on the main diagonal and 0's everywhere else. So the 2 by 2 identity matrix is 1, 0, 0, 1. The 3 by 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. The 4 by 4, notice that there are 1's along that main diagonal from upper left to lower right, Okay, right along there. Everything else is a 0. In fact, if you recall back to using matrices to solve six-dimensional equations, when we did the augmented matrices, this identity matrix is what our goal was on the left-hand side to solve the solution. And what I want to show you simply is that if I multiply by the identity matrix, that nothing will change. Okay? So if I do this matrix multiplication, I'm going to multiply the first row by the first column. Okay? Which actually I can't do because I have a 2 by 2 times a 3 by 2. So I can't do that. So let's fix this. Let's multiply. Let's keep the second matrix. Let's use the 3 by 3 identity matrix times the 3 by 2 identity matrix. So we're going to do the first row, 1, 0, 0, times the first column, 2, 4, negative 7. 1 times 2 is 2. 0 times 4 and 0 times negative 7 are all 0, so we just get 2. When I multiply the first row times the second column, 1 times 5 is 5. 0 times negative 3 and 0 times 6 are 0, so we just keep the 2, 5. Now when I multiply the second row times the first column, we do 0 times 2, 1 times 4, 0 times negative 7. Notice that we only have the 4. Second row times the second column, 0 times 5 is 0, 1 times negative 3, 0 times 6 is 0. So everything is zeros except for the term that's there. 0, 0, 1, the third row times the first column, 0 times 2, 0 times 4, those are 0. 1 times negative 7 is negative 7. And then finally, 0 times 5 and 0 times negative 3 are 0. 1 times 6 is 6. So notice when you multiply by the identity matrix, nothing changes. It's the same as multiplying by 1. 1 times 5 is 5. Okay? So there's a quick look at matrix multiplication. It's tedious more than difficult, and it's also available to you in the calculator. Again, I hope that these videos are helpful for you. If they are, please remember to like or subscribe.